Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Einstein can hear you, Reg.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu was trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Hey, everybody, welcome to the live stream. I'm your host, Ashton Forbes. Guys, wow, what a time it has been. If you did not check out the Hard Truths podcast with Dr. Yu from NASA, definitely go check that out. We're going to be talking about that a little bit tonight. Also, MH370 stuff has obviously hit a major crescendo over the weekend, had almost 50 million impressions just on Twitter, on X, talking about it. Didn't have one community note stick to any post, which goes to show you that people are waking up. You can also just see the evolution in people's thought process. And some people may say out there, why does that matter? Why does MH370 matter? Well, the only reason we are talking here tonight at all is because of those videos. It is because of the science in those videos and understanding it and getting to that point. And I sat there thinking today before the stream about how crazy it is that we've gone from investigating this missing plane to now talking about quantum mechanics. The other video that you need to watch, if you have not watched it, is the ENG8 cold fusion demonstration. I think we've found the next thing. Like, I can't believe I'm saying this, but one of the things I said early on is that we would find out the science and the physics, which we're going to talk about tonight. My goal tonight is to try to blend some newbie understanding of light, quantum mechanics, general relativity, Einstein's understanding, to the more advanced understanding that we've come to realize that, you know, light is not actually a particle and what that means. Now, we've come so far in this journey. Some people have been posting, talking in the comments, replying, saying, Ashton, you've gotten to the point where you could build something. Many of you also probably as well. That may be the case. But the goal here is not to build something. There are lots of people out there building stuff. What I'm doing, what we are doing here collectively, is we are leveling up. We are leveling up our knowledge, not our muscles, but our brains. We are making ourselves smarter and smarter and smarter. And my direct goal for you all is, through these live streams, to teach you the physics in a way where you can defend the points, that you can defend the arguments against the Neil deGrasse Tysons of the world, because you already know what they're going to say. You already know what they're going to say. For example, they're going to say that, oh, how does Yuan theory explain the photoelectric effect? Einstein won a Nobel Prize for that. You're going to say, watch Ashton's live stream about that. So we have found the science out there, and we've been leveling ourselves up, and something amazing has happened. Something amazing happened where I don't want to get too excited about it, but this is a little, I could have done the whole, like, guys, there's an announcement tonight. Get ready. Watch the stream thing. I could have done that. I actually didn't even post the stream. I probably should do that. But But I'm pretty confident that the NG8 interview uncovered what we've been looking for, which was actually not necessarily NG8, but we found Randall Mills, brilliant light power. Now, I want to talk about this for just 1 minute to get you guys ready, because I wasn't ready to talk about it tonight in full. I feel like it's what we're going to do is on Friday, we're going to do kind of an old school investigation stream, and we are going to dig into everything about this company. Everything about this company. By the way, 2 other quick things that I just forgot to mention. I'm going to be talking to Randall Carlson, the gray bearded man. Hard truths. That's going to be the next one. And then the hard truths after that, I'm probably going to talk to somebody that has researched Randall Mills and the hydrino and brilliant light power. So, yeah, there you guys go. And I almost guarantee you the very first thing that Randall Carlson and I discuss is the letter to Ashton Forbes. So, going to be an interesting one. Okay. Let me just quickly tell you. So, we've been looking for a low energy phase transition, a negative energy event. And just in the last couple months, we realized that the MH370 ZAP is actually ultraviolet. It's ultraviolet light that's releasing. That's why it's black in this. This is actually ultraviolet. So we actually figured the physics out. Why is that black? Because ultraviolet light shows up as black in a thermal video. And then, of course, the moment you find out something like that, you go, okay, wait a minute. I mean, we're kind of narrowing it down here, right? Why UV light? Exactly. It has to do with this phase transition that occurs. Is that if you cause this negative energy event to happen where if you lower the equilibrium point of the hydrogen atom. So the way to think about it is that we have this box of space-time and everything in this box of space-time and all the little lattice structures, everything's connected, right? And we're shrinking this down. We're shrinking this down. And what this effectively does is this lowers the normal equilibrium point. If we're sitting on top of the water level sinks. The water level sinks. So when the water level sinks, it changes the equilibrium point of the atoms, all atoms. And this causes an energy release. And if you go and look into what type of energy release this causes, this negative energy event causing this reduction in the refractive index of space-time, the exact thing we've been talking about, the polarizable vacuum of Hal-Puthoff, just electrifying a region of space-time. What this causes is there to be an ultraviolet release of photons. Ultraviolet release of photons. So, when I started looking into brilliant light power, as I was told to from the NG8 people, the first thing I see is that they are collecting extreme ultraviolet light. That's what they're doing. They're collecting extreme ultraviolet light. And that's exactly what the photon burst is an extreme ultraviolet. So far that it's almost into, what's the next band or whatever? X-ray or something? I don't know. The next band up. So whatever Randall Mills is doing with his hydrino, it appears to be the same chemical process as the videos. And it turns out Randall Mills has been getting attacked and discredited like crazy. And what Randall Mills is saying is that n equals 1, Planck's, it was actually, I think it was Schrodinger's that did the equation, basically showed, the idea was that we thought we couldn't go below the equilibrium point. We thought there's no way to go like this. Randall Mills came in and said, we can have fractions of 1. We can go below n equals 1 in quantum mechanics. And if you go fractionally below 1, to me, that's the same as going down, lowering your sea level. So just conceptually, what Randall Mills is saying sounds exactly the same as what I think we're seeing when the orbs converge on the plane and the plane zaps out and this ultraviolet release of photon happens. So Friday, we're going to figure out what's going on, because the reaction I got from Randall Mills when I emailed him, my spider sense was tingling. Something isn't right. I email Randall Mills and he gives me a very short response. It didn't really make any sense. And now I'm kind of sitting here thinking, this guy's been doing this research for decades. Where's the money coming from? Where's the money coming from these guys to be doing this research for so long? I mean, this gotta cost a lot, and there's no product. Is the military involved in this? I'm starting to wonder, can we figure out who the people were who figured out the orbs? Like, maybe Randall Mills isn't making plasma orbs that can fly around, but like maybe his technology led to that. You know what I'm saying? Something's weird, guys. So we're going to put Randall Mills on the map. And last point, and then I swear we'll get on to the next thing. This does connect, by the way, all this. I think we are going to be able to blow up the fusion scam, metaphorically speaking, in case any feds are out there. Don't take what I said literally out of context. We are going to be able to expose the hot fusion scam before it even has a chance to kick off. This is probably what will get me killed more than the Malaysian Airlines thing. I strongly suspect right now that they have fusion planned out. They have fusion planned out, a rollout plan for fusion, and it's going to be a intentionally gimped version of fusion that they know they can do it better. And I think they've got it all planned out. They know which companies are going to do it, everything like that. And Brilliant Light Power might be one of those companies, maybe. Or one that's going to, what it's going to be is it's going to be controlled by the government, where the government dictates like how efficient it can be. That's basically probably how it's going to play out. So we might be able to expose it in a way where like we can actually impact the markets. We've gotten big enough now from just like a community standpoint, where like if we start really just exposing these companies, just airing their dirty laundry out, any weird, like who knows what we'll find. We could actually like impact the markets, where people either we find out that like they knowingly have super advanced technology and they've been holding back from their shareholders or something like that. Or, you know, who knows? Just as hypothetical only. Tonight, the photoelectric effect. Why? Why are we talking about the photoelectric effect tonight? Why does this connect to Randall Mills? How is all this stuff connected? Well, it turns out that once upon a time, all the smartest people in the world thought that light was a wave. Everybody said, light is a wave. And then this big brain bastard came along. I don't think he was really a bastard, actually. Patent clerk named Einstein. And he said, nah, those Nobel Prizes you got about your waves, that's some bitch work. And he came in, he said, light is not some wavy thing that's just constantly feeding energy. It's a packet. It's a packet floating around in little packets here and there. And then everybody said, no, Einstein, I don't like you. You're not cool. I don't like your ideas. And unfortunately, all those wave people were right. They were right. They were bullying Einstein, and they were right. And the woke people won, and they somehow changed public opinion, and everybody started believing Einstein. And now we're in a situation where everybody thinks that everything's a little particle flying around, right? We all think there's little apples flying around, little light. It's a little apple bouncing into your eyes all the time. There's little particles of apples hitting you in the eyes. Yeah, that's how the world works. Yeah, it's little particles of light. Even though all the experimental evidence, like every time you run an experiment on light, shows it's clearly a wave. But nope, we got to think of it like particle. Okay, that was the common man, very abridged version of what the photoelectric effect is. We're going to do a couple different versions here for the different skill levels, right? So Einstein came in. And by the way, that is the only thing Einstein won a Nobel Prize for. So the funniest thing is that Einstein won a Nobel Prize for the photoelectric effect, and this is the thing the other physicists gave him the most shit about. They said this was the thing that they actually didn't agree with. General relativity and what have you. You know, everybody agreed with all that. Okay, so before we jump into this, we're going to have a little bit of fun. I've got some videos prepared. You know what? Let's first okay, let's do this one first. Trying to decide what. Wait, what happened? Why? There it goes. What's that? What is this? Oh, okay, there we go. I was listening to myself. Okay. Chat, you know what it's time for. Science is a liar sometimes, chat. Here it is.
Here, present some egghead scientific argument based on fact. I'm just a regular dude. I like to drink beer, you know, I love my family. Rock, flag, and eagle, right, Charlie? He's got a point. No, he doesn't. What? See, Charlie, these liberals are trying to assassinate my character. I can't change their mind.
These liberals in there. Science. I was trying to assassinate my character, chat. It's true. It's a true story. This is a joke, but actually it's just real. It's just real, though.
Won't change my mind because I don't have to. Because I'm an American. I won't change my mind on anything, regardless of the facts that are set out before me. I'm dug in, and I'll never change.
Mac, look, you're wasting our time. You're not going to get us to not believe in evolution.
And why is that?
Because the smartest scientists in the entire world all agree that it's real.
I'm glad you brought that up.
Oh, the smartest scientists in the world all think that light is a particle. Is that the case? Do you guys, can you tell how this is going to go, everybody? How does it go for the smartest people in the world?
Because, Mr. Reynolds, science is a liar sometimes.
Oh, boy.
This is Aristotle, thought to be the smartest man on the planet. He believed that the Earth was the center of the universe, and everybody believed him because he was so smart. Until another smartest guy came around, Galileo, and he disproved that theory, making Aristotle and everybody else on Earth look like a bitch. Of course, Galileo then thought comets weren't optical.
Chat, have you ever seen someone get served as hard as Galileo served Aristotle? There's no coming back from that. You can't even show your face on social media after that.
Illusion. And there's no way that the moon could cause the ocean's tides. Everybody believed that because he was so smart. He was also wrong, making him and everyone else on Earth look like a bitch again.
Boom!
And then,
bitched again.
Best of all, Sir Isaac Newton gets born and blows everybody's nips off with his big brains. Of course, he also thought he could turn metal into gold and died eating mercury, making him yet another stupid bitch.
Are you seeing a trend?
Are you seeing a pattern?
No.
Mr. Reynolds, these were all the smartest scientists on the planet. Only problem is they kept being wrong sometimes.
This isn't
Chat, I mean, look at how can you argue with this logic? My man knows how to work a crowd. They're wrong sometimes. All of them, the smartest people in the world.
insane, you
Space
fool.
Oops.
I'm a fool because I have more faith in the saints that wrote the Bible?
Yeah, because you just read the words of a bunch of guys that you never met, and you just take it on faith that everything they wrote was true.
And what makes you think what your scientists are writing is any more truer than my saints?
Because there are volumes of proven data, numbers, figures. There are.
Have you seen the data, poured through the figures, for yourself? Have you done the research, chat?
Fossil records.
Oh, fossil records. I didn't even think about the fossil records. I guess I'll concede. Oh, wait, one more thing before I do, Mr. Reynolds. Have you seen these fossil records?
Have I? Huh?
Have you poured through the data yourself? The numbers, the figures?
Well, no. No.
Oh, interesting. So let me get this straight, Mr. Reynolds. You get your information from a book written by men you've never met. And you take their words as truth based on a willingness to believe, a desire to accept, a leap of, dare I say it, faith?
Come on. Look, I don't even know how I'm supposed to respond to that. Come on. That's a false equivalency.
Just answer the question, Mr. Reynolds.
Sure. Yeah. Okay.
I rest my case.
Oh, that got me. Yeah.
Thank you, Frank. You won.
Well, chat, I don't know about you, but I'm convinced science is a bitch sometimes. Now, what is the lesson that we can learn from that valuable educational science video that can be shown to children? The lesson we can learn is that we shouldn't get too egotistical about what we think we know science to be. Science is not what I was taught in school. Science is not what I learned in a book. Science is the study of observable reality. So you may say, Ashton, how do I distinguish science? The study of observable reality. The answer is the experiments. We look at the experimental results and we interpret those results, and that's called making a physics model. See, guys? Science. So, what we're going to do tonight is we're going to look at the photoelectric effect through the lens of Dr. Yu's muon theory, using the help of float head physics to assist us. Now, before we do that, let me re-explain Dr. Yu's muon theory for you guys. By the way, NASA might, guys, apologies to my conspiracy theory followers who are always hitting on 19. In fact, maybe you need to hit on 19 a little bit more. What if it's that NASA was not lying about space? Maybe the reason why we didn't go back to space isn't that space is fake and gay. What if space is super real and NASA actually is secretly hiding the super smart people that figured everything out, and they just have to pretend to be stupid? The PSYOP was one more layer deep. You had to go one more layer deep on the PSYOP. They're actually expending a huge amount of effort to appear to be retarded to the public. Like, they have to do big plans of, okay, all of our IQs are like 150. How do we appear to be like room temperature retarded IQ when we talk to mainstream media today? Okay, here, I got it for you. Go out there and tell them that we lost the technology to go back to the moon. Perfect. Go out there and say that to CNN. Boom. See? You guys aren't, sometimes you got to hit on 19, but only on the right time. You know that 2's coming, chat. Okay, so here's the real explanation for the photoelectric effect. I'm going to use my mug as an example. What happened was we discovered electromagnetism. And quickly what was observed was that we can shoot light onto, let's say, a metal. And when that happens, there is a release of electrons from the atom. The atom has electrons in it. The electrons are being released from it. So we're shooting our light, and it hits our atom, and electrons are being released. Okay. That's normal, right? Nothing wrong with that. If I shoot something at this mug, I expect it to move a little bit, right? Or there to be a reaction, a conservation of momentum, equal and opposite reaction. Something must happen. That's not a problem. But here's the problem. They increased the brightness. So let's say, imagine going from a 50-watt bulb to a 100-watt bulb. It's a lot brighter now. They said, okay, I just made the light much brighter, much more kinetic energy coming from the light. And it's hitting my mug. So what should happen? The electrons should be shot out at a higher speed, right? I mean, I'm putting more energy in. You should have more energy come out. That's what should happen. And that's not what happens. Wow. So what is the experimental result we need to explain? We shoot light at a metal or an atom of some sort, and we can get electrons to break free. But when we make the light more intense, more bright, increase the amplitude of the wave of the light, the electron doesn't break free with any higher speed. Huh. That is a very unusual phenomenon. So then we had to explain this. And we found something very, very weird. We can cause the electron to break free with higher energy. How? What if it's not the intensity of the light that causes it? What causes the electron to have higher energy when it gets released? The color. The color? Like the color, like this is yellow? Yes, the color. The wavelength, the frequency of light changes the kinetic energy at which the electron is shot off of the atom. Not the intensity, not the brightness, the color, the frequency. Huh. So what Einstein discovered, why he won a Nobel Prize, why we all believe in the photon, is that Einstein realized that we have to look at light differently in order to interpret this experimental result. In order to interpret this experimental result, we can't look at this relationship as this linear relationship between the laser shooting the light beam and the electron that's released. Instead, there's this like stepwise result. And it's based on frequency, not based on amplitude, not based on the intensity. So Einstein decided that we're going to create something called a packet of light. And we now call this also like a quantum unit of light. It got unified with Max Planck's theory of quantum mechanics into this idea of this quantum photon of light that's some imaginary particle. And that the only way that this whole idea of why we don't see this continuous release of, or we don't see this continuous energy release of the electrons when we turn up the intensity, must be that there's this packet of photons and we have to change the size of the packet. Change the size. He calls it like changing the size of the spoon to cause more energy to come out. So, what is the alternative answer? Well, somebody already said it before I even asked the question. I asked Dr. Yu the answer to this question, and his answer was resonance. Now, I'm going to blindly play this clip without knowing exactly what it's going to say, and hopefully it's relevant. Here we go. Light not a particle. Why is light a wave? Or is light a wave? Is light actually a particle and a wave at the same time?
My quick answer is, after I studied this one, my quick answer, light is 100% a wave.
So what would be your explanation there for like that we can change the size of the spoon by changing the frequency? How does that, we're like changing the excitation by doing that? Like we're making the excitation more impactful, or?
That's where resonance comes in.
Okay.
You need to hit the resonance frequency, right? You adjust frequency. Not every frequency is a resonant frequency. Only in the resonant frequency, you use the smallest energy can propagate.
Anybody were to say, oh, they want to challenge it, which I love for people to challenge, is that even Leonard Susskind was asked about, if we remove all this energy, how can there be something there still? Well, how can there be something there? And he goes, yes, there's something there, and it's electromagnetic. He says it has charge. And they go, how can it have charge if there's no mass, if there's nothing actually, if there's no energy or mass there? And that he says, I don't know where it can come from. Well, you just said it. There must be a medium, and that medium's electromagnetic, and it's the 0 point
interact with moving particles are magnetic too, right? They are interact.
Everything's magnetic. Okay. Wow. So the answer is resonance. Now, I want you to think about this while we're going through watching some of these clips here, because think about that exact same thing that we just said. It's not the intensity of the light that is causing the kinetic energy of the electrons to be released with more energy. There's some kind of stepwise process that's related to the frequency. So what is going on? It's resonance. It's always been resonance. You have two waves interacting. How do waves interact? They interact with resonance. So if you have two waves that are out of phase, they're not going to interact. When they're in phase and they hit a resonant frequency, they're going to interact. It's actually hilarious that Einstein came to this conclusion, because to me, it seems obvious that the conclusion of the photoelectric effect is that Tesla was correct. How can you look at, just look at it like this. Let's just recap what I just said without even looking at anything else. We increase the intensity of the light shining on an object, shining on an atom. Increase the intensity doesn't cause, it causes more electrons to be released, but it doesn't cause each electron to be released with more energy. Doesn't make any sense from a perspective of physics. If I run into something, my energy should be conserved and pushed into that thing. It shouldn't be spread out over three different things. That doesn't really make sense. But we found out what the real mechanism is. There is a real mechanism that can cause the electron to be released with more kinetic energy. The mechanism is color, frequency. You don't change the intensity, just change the frequency. That just to me says, okay, that's resonance. Like when I change the frequency of my radio, I'm tuning in to the radio station. When you change the frequency of your light, you're tuning in to the frequency of the object that you're shooting the light at. Thank you, Matt, in the Pilled chat. And thank you guys, my Pilled followers. Love you guys. The more I watch these shows, the more I'm starting to resonate with the light as a wave. To be honest with you guys, I was somebody that was all about the particle stuff before all this. And now I'm sure there's no chance that light is a particle. Light is definitely not a particle. So let's take a listen to my man, Floathead Physics, explain it, okay? I think this is it. Hold on. Do I have the right video? I think this is the right one.
disaster. We called it the ultraviolet catastrophe. But I never understood what really happened. Why did it happen like that? I mean, surely you can understand the mathematical derivations. And by the way, if you want to do that, there are some beautiful videos out there and have why classical physics leads ultimately to this ultraviolet catastrophe. And so if you're ready for this, let's begin. So Feynman, what's the whole issue with this hot glowing things? Well, Feynman reminds us that it's not just these metals that glow. Everything, including you, me, and donkeys, we all glow due to our temperature.
Go right here.
Physics tried to explain it and tried to predict this. And when they did, that was a disaster. So Feynman, help me understand why did the classical physics, why did classical physics break down? What is a disaster? Help me understand without any equations. And Feynman says, Mahesh, what happens when you pluck a guitar string? And I'm like, what? You get music. And Feynman asks, but what causes that music? Sound waves. But what causes the sound waves? The waves on the string, Feynman. But what kind of waves? I'm like, oh my God, standing waves. Yes, standing waves. Guitar strings or strings of any music.
There we go. Standing waves, chat. So, why did Ashton spend all that damn time talking about waves, explaining why light's a wave? Why is Ashton showing this video? The first thing we need to understand is light is a wave. What does that mean about particles? Why do we see things as particles? Why do we see things as solid? We see things as solid because light, everything, is actually waves at the smallest scales. It's all waves. And if everything is waves at the smallest scales, then you interact with waves with other waves, right? And this is what I think Dr. Yu is trying to say, is that you can have particle-like magnetic maybe even the smallest thing is a particle. I mean, maybe is the smallest thing a particle or is the smallest thing a wave? I don't know. But we have these wave-like interactions which drive our visible reality.
Instrument for that matter, creates standing waves. These are different from traveling waves, which, well, they travel. But you know what? I find the word standing wave very weird, because wave is where you have energy moving from one point to another without the particles themselves moving. But standing wave, that means, is stationary motion. It's an oxymoron, kind of like bittersweet or acting naturally or internet privacy. But Feynman reminds us that it's called a standing wave because you get it when you have two traveling waves in the opposite direction and they interfere with each other. Again, check out this cool visual I did using ChatGPT and some video editing. I'm not trying to sell a course over here, but I'm super, super happy about.
So this I wanted to just show, because also thank you for that donation. I have no idea what this means. Have the moonlight. I don't know what that means, but thank you very much for that donation, Raphael. So the other thing about this is that this also connects to Tom Bearden and phase conjugation. This is what Tom Bearden was talking about, is manipulating waves and interacting waves can manipulate gravity. Excuse me, by potentially either constructive or, sorry, that was destructive or, constructive interference. So I'll skip ahead. And then this also ties interestingly into this idea of black body radiation, where they will Planck at the same time, while the photoelectric effect was being discovered, or maybe a little bit earlier, Planck is also discovering there's this black body radiation, that everything is radiating energy out. And so they start to realize that this energy, if you imagine an empty box or a box that's not empty, you can have all these modes of energy and the heat, and you can pull this energy out. And this energy is always coming off of every object all the time. This energy radiating off of us. And during Max Planck's discovery of the black body radiation is when we found Planck's constant. And so there's this connection here to the photoelectric effect, in that Planck's constant exists in the photoelectric effect as well in the equations. Meaning there's some universal connection between this idea that light isn't acting like a direct stream of particles. It's acting like this packet. There's some connection between that and this energy that we are radiating all the time. And this kind of makes sense, right? Because think about what we said here. You're shooting light at an object. and electrons are released. And we're also saying that if you're just standing around all the time, you're releasing energy, and black body energy radiation is releasing off you all the time as well. So maybe they're the same thing. Maybe the black body radiation is because of us interacting with the medium all around us. The answer seems pretty clear. How do you explain all this stuff? The same way Dr. Yu did. Light is a stimulation of the medium. We're in a medium all the time. There must be a medium for any of this stuff to make sense. So let's go to which part? Crap, I can't remember which part I said. Oh, okay, here we go. Here it is. Okay, so then there's this expartition theory. I'm not going to show the video part of it, but basically says that if there is three dimensions, this cube of space, energy is averaged over that all directions. Energy is averaged over all that directions. But here's the thing. There's an additional degree of freedom. So you have up, down, left, right, back and forth. There's another degree of freedom that's allowed. Spin. In fact, maybe I'll go to that part where he talks about that. I think he talks about it right here.
Energy in the vertical axis. But since there's no preference for any axis, on average, the energy has to be equally distributed among the three directions. That's what the equipartition theorem says. On average, energy, not water, is equally distributed among various degrees of freedom. Degree of freedom is a fancy way of describing the different ways in which energies can be stored. So for air molecules, the kinetic energy can be stored in these three different axes, and so there are 3 degrees of freedom. And so according to equipartition theorem, if the average energy for each degree of freedom is E0, then the total energy should be 3 E0. Makes sense, right? And by the way, if we had, say, diatomic molecules, like oxygen molecules, for example, then there would be more degrees of freedom. And at this point, I'm like, wait a second, fine, we're still in 3 dimensions. How can you have more than 3 degrees of freedom? Well, now, along with the motion along the 3 axes, they can also spin. That's additional ways of storing energy. In fact, they can spin in a couple of independent ways now. And total, therefore, they get 5 degrees of freedom. So in this particular case, if on average, the energy per degree of freedom is E0, then the total average energy would be 5 E0. Makes sense?
Wow. Thank you, In the Bushes, for gifting the can. Can of limonada. That's what I am now. That's what I've become. So, spin. So yesterday when I just tweeted magnetism and spin, spin is a form of energy, angular momentum. And what was it that Salvatore Pais, remember Salvatore Pais, U.S. Navy engineer, has the UFO patents? He says that we can potentially manipulate space-time using accelerated vibration or spin. Interesting. So obviously Sal is looking at this vibrational energy, but in general, he believes that we can amplify energy. Dr. Yu believes that we can amplify energy. And now here we're seeing that when we really get down to the basis of physics, spin is one of the degrees of freedom for energy as well. Imagine if we have a frictionless spin and we can increase the acceleration. That's infinite energy. Okay. Here's another really cool image of standing waves. Here, where is it? Here we go. Because the other thing that Dr. Yu said when we talked to him was he mentioned that they're like, when I talked about Terrence Howard, the octaves, he says there are certain harmonics. So you can imagine here's n equals like 2 at the top here, your wave. You've got this one here, n equals 3, n equals 4, if you want to imagine it like that. So you can see actually that you can just, by increasing the number, increasing the frequency, you can see that there's a relationship between the waves, essentially. which to me, excuse me, I'm not personally super convinced on the whole periodic table in terms of this, but it's starting to make more sense, because now if you're saying that everything has a resonant frequency, everything is waves, then elements are really just waves. And it's just like an element is the base form of some standing wave. So you're saying, what is hydrogen? Hydrogen is just a standing wave of a certain exact structure, geometric structure. That's it. And then everything builds upon that. That's the theory behind this, at least.
Electromagnetic waves in that metallic cube, they are three-dimensional. And I'm like, okay, how does that change things? Well, in 1D, there's only one way to set up each wavelength. But turns out in higher dimensions, there are more than one ways to set up each wavelength.
Make this bigger.
And it's harder to visualize this in 3D, so let's look at it in 2D. Again, this is something that I coded myself. So, but anyways, okay. So if you look at the longest wavelength, which is analogous to what we see over here in 1D, then that looks like this. And again, there's only one way to set this up. Okay. However, if you were to go for the next higher frequency, you can set it up this way, or you can set it up this way. These are the two ways in which you can have two lobes. Look at that. So since there are two independent ways to set up this particular standing waves, there are 2 degrees of freedom for this particular wavelength, not one. And for even shorter wavelengths, since you get more lobes, you can even set them up in even more ways, and therefore you get even more degrees of freedom over there.
So, what are we saying there? Why is this so important? What are the degrees of freedom? So imagine all the directions that I can go in. I can go that way. I can go this way. The degrees of freedom are all the different ways something can move. And then what's another degree of freedom? If you have every dimension that you add, you get more degrees of freedom. When you increase your standing wave, you get more degrees of freedom. You get more ways the wave can be set up. And when you add another dimension, that wave gets more and more complicated. The waves get so complicated, they get hard for us to comprehend. One of the degrees of freedom is spin. So you have all these degrees of freedom, right? And this is what makes it become really difficult for our human brains to even comprehend. What is energy? Energy can come in all these different forms. Energy can come in any form of movement in our three-dimensional space. I present this because I want people to understand that a couple of things. One, energy is everywhere. Of course, there's infinite energy. Because when you add all this up, you go, there must be infinite energy out there. The other thing is, now realize all these modes, these wavelengths, especially the 0-point energy, it's everywhere all around us all the time. All the different modes in every possible direction, everywhere. If you imagine that we are the fish in the fish tank. Remember, actually, Dr. Yu said this. It was actually really cool. Dr. Yu said, we're fish in the fish tank. The fish doesn't see the water. Exactly. The fish doesn't see the water. That's us. So when somebody says, what is polarizing the vacuum? What is that? What is space-time metric engineering? What is manipulating space-time? Well, Dr. Yu told us. Light is a perturbation in the medium, a disturbance in the medium. So when we're manipulating space-time, all we have to do is we have to electrify the region of space-time. Push out all that white noise. Imagine you look at one of those old TV screens with the white, the snow, they used to call it, on the screen. And then the Ringu comes through. Your television. Imagine if all of a sudden all the white noise on the TV just went away. The white noise all just gets pushed out. That would be my visualization of polarizing the vacuum. You're basically creating order from disorder. Also, the Ringu is coming for you guys. Okay. Let me think. Is there anything else we need to look at here? So basically, the number of degrees of freedom gets kind of out of control. Now, I wanted to show you that part. Now, this video, this next one I'm going to show you is even better. Now, this one's actually directly about the photoelectric effect, but I needed you guys to understand the quantum mechanics stuff a little bit more before we get to that, okay? Because what's my whole argument? The whole argument that I'm making here is that the photoelectric effect is incorrect. I mean, it's not that it's necessarily wrong. Obviously, the experimental results are correct. It's the interpretation that's wrong. The interpretation that we have these packets of light and we're just going to change the size of the packets, that's what's wrong. That's not the right way. That's not what's going on. We are creating a wave, and our wave is interacting with the wave that we're shooting that thing at. That's why it's releasing an electron that's going faster. So imagine now we say, okay, I'm standing here and this thing shoots into me. And I'm going to be like, oh, okay. Right. I'm going to shoot off. Now imagine I'm spinning really fast. Right? Now imagine all those degrees of freedom. I can be spinning this way. I could be spinning this way. I could be spinning any different direction, right? Because we have 3 degrees around us. So what are we starting to realize now? We're starting to realize, what happens if I shoot something and hit something that's spinning? Well, it turns out the direction in which I hit that thing that's spinning, my direction that I throw it at, matters a lot, because it could be oriented this way, it could be oriented this way, it could be oriented this way, it could be oriented any different direction, in a random direction in space. If something's spinning, then you need to hit it in the exact right way. This is the same concept as if I'm shooting something with a frequency, I need to hit it with the right frequency in the right way. To me, this is the answer. Why do the electrons not shoot out with more energy? Because hitting it with more light at the same frequency isn't going to do anything. You can keep running into the brick wall, but you're going to never go through that brick wall until you get a sledgehammer. Simple as that. And if you get that sledgehammer, why does the sledgehammer break through? Because the sledgehammer was made to break through, because you hit that resonant frequency and now you are just hammering through. And that thing is just a matter of time before it cracks. Every frequency, is just beating on it. Interesting. Okay, so this one here. So here's the guy that figured out the photoelectric effect, why it even exists. Why is this not working? What's that? Oh, here we go.
But he probably didn't care much because he was celebrating the discovery of electromagnetic waves and was probably too busy having a unit named after him. But soon, the electrons were discovered, and it then became clear what was going on. The ultraviolet light ejected electrons from the metal. This made the spark bigger, and it was called the photoelectric effect. And this led Einstein to revolutionize our understanding of light, eventually earning him the Nobel Prize.
So, someone made a spark gap. Look at that. There's a spark gap. That's how we discovered electromagnetic waves. That is basically the very basis for producing cold plasma. That's the very, very most basic thing to begin producing cold plasma. And then they shoot it with a laser beam. That's what this is right here. And what happened? The plasma grew. The plasma grew. The arc grew. So they were like, wait, what? Light is causing an interaction with this metal surface? It's causing electrons to be released? Why? Why? And then, so here, they kind of just explain, I'm not going to show it. So he just kind of explained basic physics like I told you guys, right? He says, okay. He says, we can figure this out. He says the electron must have some kinetic energy when it gets released from the metal. How do we measure that kinetic energy? We can't like actually look at the electron. It's too small. There's no way to actually look at it. So how do we measure the kinetic energy of the electron? Well, let's do the opposite. Let's measure how much energy it takes to make it so the electron doesn't get released, to hold the electron back. So what do? They create an artificial electric field, right? They create this electric field and they create a repulsion effect. And then they shoot the light at the metal with the repulsion effect containing it. And then they measure to see if there's energy flowing. And if there's no energy flowing, then you figured out the amount of energy it requires to stop that electron. You figured out how much energy that electron has. So this is actually super genius. I'm going to let him explain it here. Super genius for them to figure this out, because this shows that this effect is not some imagination thing. It's not some, somebody misinterpreting something. The effect is very real. The question is, how do you conceptualize the effect? How do you explain the effect? Wait, which part is it? I wrote all this down. Oh, here it is. This should be good. Right about here.
We use another metal to collect the electrons, which we're going to call the collector, but put a negative voltage to the collector, then that will repel the electrons and it can make the electron stop. Now, if it takes a little bit of voltage to make the electron stop, that means the kinetic energy of the electrons was very little. But if it takes a lot of voltage to make the electron stop, that means the electrons had much bigger kinetic energy. Makes sense, right? And I'm like, yeah, that makes sense. But how do I know if the electrons have stopped or not? Like, I can't see them, right? This is where you put an ammeter. If the electrons are collected, then there will be a current and the ammeter will detect it. In fact, in this particular example, there is a current. That means I know the electrons have not stopped. So this much voltage is not enough. So let's turn up the voltage until the current just stops. So at this point, I can now visualize that all the electrons that are coming out of here must have stopped and must have turned around. None of them are getting collected. So in this case, it takes 3 volts to stop these electrons, right? Now, imagine another photoelectric experiment in which it took, say, 6 volts to stop the electrons. Then I can immediately compare and say that, hey, there, the electrons must have come out with more kinetic energy. In fact, about twice as much kinetic energy as over here, because it took twice as much voltage to stop it. This means this stopping voltage, as we call it, is a direct indicator of the kinetic energies with which the electrons.
Okay, so just like I said, so we have a way where we can now check to see how much energy was being released. Okay, so, and here's the thing that didn't make any sense for everybody. They said, okay, well, how is this possible? As if I'm increasing the intensity, I'm getting more electrons being released from the metal, but they're not being released with any higher energy. How does this make any sense? The analogy he gives in this video is he says, well, imagine a cannon. How much energy he says, what's the relationship between you lighting the cannon with a match and how much energy is being released from the cannon and the cannonball? There's no direct correlation. One just triggers the other. It must be a triggering effect, not an effect, not a direct connection. Absolutely must be the case, right? So that's a good analogy. So when somebody says, what about the photoelectric effect? All 600 people watching this live stream right now should say, the photoelectric effect that Einstein showed must be some sort of triggering effect. Because when we increase the intensity of light, increase the wattage, brightness on our metal, the electrons released don't get released with any more energy at all. Just more of them gets released instead. That shows it must be a triggering effect that's happening. The light is causing a trigger, something to occur within the actual medium. Okay, here's this part, I think, is the next cool part.
Cool. This time, Leonard experimented with different colors or different frequencies of light, higher frequencies like X-rays and even lower frequencies like visible light. Now, according to the trigger hypothesis, light is only triggering the electrons. So the energies with which electrons come out should only depend on the metal, right? So this means the frequency should have no effect on the kinetic energies of the electrons, right? Right? But what Leonard found was that was not true. Leonard found that the high frequency light actually made the electrons come out with more kinetic energy, and lower frequency light made them come out with lesser kinetic energy. And if light's frequency was too low, then electrons didn't come out at all, no matter how bright you made the light.
I do want to clarify, when I say triggering, Leonard was the person that Einstein bitched. And he had a theory called trigger theory, which is not the same thing that I'm saying. When I'm saying triggering, I probably shouldn't say that to avoid confusion. I mean just perturbation. So right here, why is an increase in the frequency causing the electrons to come out with more energy? How weird is it? Just remember this. You want to just blow somebody's mind. When anytime anyone brings up the photoelectric effect, you just say, why is it that it's not the intensity of light that causes the increase in kinetic energy from the electrons? It's the color. The color causes an increase in kinetic energy from the electrons. Just look at it from that perspective. If I were to tell you the color of light with which you hit this piece of metal is going to change the energy level at which the electrons are released from it, you would say, what? Why? That makes no sense. It does, though, if you understand waves and frequency. If you just ignore waves and frequency and think everything's a particle, it makes no sense at all how that could be possible. The color. I'm going to actually say this a lot because it just sounds awesome to say. Technically, it's the frequency. You all know that. But saying that the color changes the energy, the amount of kinetic energy released by the electrons, each electron. Weird. Yes, finally, someone in the chat. Some people already said this as well, probably. The other thing that people are realizing that obviously now, sound. Why have we been discounting sound? Some people should be thinking now, wait a minute. Sound is a wave. Why can't sound create light? Why not? You're telling me light is a perturbation in the medium, a disturbance in the medium. Sound is creating waves. Can't sound create light? Yes, it can. Yes, it can. And yes, it has. In the form of sonoluminescence. Sonoluminescence. Sound can create a pressure in the medium that causes light to be released. Pretty wild, huh? And it can't really be explained. I don't think Einstein could explain it with his classical theories either. Could be wrong. Yeah, I guess not a lot of people. It's hard to like find a good grasp of like what I should show for people and not be too repetitive. But for people that want to know sonoluminescence, it's obviously zoomed in. See that light get formed? That's just sound and water. Just sound waves and just water. That's it. That's it. That's all it takes. Okay. Okay, back to my guy. Okay, so we know that it's not the intensity, but the color, the frequency that changes the kinetic energy that that is released from the atoms. So to me, this is really now the answer here. The medium itself must be providing the energy. Where are all these electrons coming from? And if you don't hit the resonant frequency, then what's happening? Your light's just bouncing off of it. Like if I imagine something spinning really fast and I start throwing rocks at it, the rocks are just going to fly off of it, right? But if I spin around really fast as well, and I match my speed to the thing that's spinning around really fast, I could slow it down. I can stop it. I can do all kinds of stuff with it. That's pretty much how we need to be thinking about the photoelectric effect. And I guarantee you, As somebody that know, I don't know any I know, like, nothing about physics. Obviously, that's not true, but it should be pretty easy to look at physics from the lens of the photoelectric effect being this resonance effect. And then I think you're probably going to find a bunch of stuff that confirms this from other perspectives. That seems to be how this always goes down, is that people say, Ashton, you're a crank, blah, blah, blah. And I say, I have no reason to believe this is real except for these crazy videos I saw that say that this must be it. And then we find out there's some crazy rabbit hole and that, yep, this physics thing might be real. Einstein might be wrong, etc. Before we get to the last part of this, I want to say that Einstein, I actually agree with the criticisms of Einstein from the classic physicists that would say that the photoelectric effect is probably Einstein's biggest blunder. Relativity, genius. Relativity is probably E equals mc squared and relativity are two of the most foundational physics concepts ever, up there with F equals ma. And E equals mc squared is huge because of the idea that mass is energy. Mass is energy. And that idea feeds directly into the idea that everything is a wave. Energy is light. Light is a wave. Mass is energy. Mass must be waves too. Simple. Simple. E equals mc squared. Vitally important. Anybody that tries to discount Einstein, you're just up the creek without a paddle. Cannot be denied how huge that is. And that's only one of the two major contributions. The other contribution, and actually that's not even, he's had many. I mean, Bose-Einstein condensate, now that you guys bring that up, yes. Einstein-Rosen bridge, yes. These are things that I'm not even mentioning. The other one, though, is relativity, frame of reference. Einstein told us the speed of light is constant. But that's actually a weird thing to say because it shouldn't be constant. For us to be living in this shared universe, the speed of light should change based on our relative perceptions, based on our relative movement. Because if I'm moving in the direction of the speed of light, it should appear to go a little bit slower. But in my frame of reference, the speed of light is always measured the same. What? How can that be possible? How can it be possible that I can move in any direction against the speed of light or for the speed of light, but in my own frame, whenever I measure it, it's always the same? This is what causes time dilation. This is a paradox in and of itself that the universe autocorrects with time dilation. Einstein showed us we're all living in our own little bubble. We're basically avatars in a video game living in a little bubble, but our own little bubble is not perfectly in sync with everybody else's little bubble. They just look to be in sync with one another because we're all on the Earth at the same time. But if I were to go to a different planet and come back here, our times aren't going to be in sync anymore. I could go live on a different planet for 10 years, and I could come back here, and it could still be today. And I would be 10 years older. That's possible. I could also go live on another planet for 10 years and come back here, and it could be 1,000 years later. That's also possible. That's how time travel really works. So Einstein showed us two of the greatest things in physics. Relativity, which I just explained, that we're all living in our own bubbles, and that mass is just energy, which if energy is a wave, then mass is a wave too. So Einstein, absolute genius, no question. Absolutely wrong about the photoelectric effect. Absolutely wrong about the photon. That's where Tesla comes in and takes over. And Tesla says, think of everything in terms of energy, frequency, and vibration. And that's where Einstein screwed up. And he said, I'm going to come up with this photon particle to explain this, when he should have just said, everything's going to have a resonance effect and harmonics of that resonance as well. And so when we are seeing these experimental results, which show this stepwise motion, it's because we have this harmonic resonance effect that's happening between the light and the metal or the material. Yeah, actually, quantum gravity always comes in with really good insights. He was overthinking it. This is a classic case of overthinking it. He was trying to come up with some new explanation when it was just, the answer was simpler than it needed to be. And so why did Einstein get so much shit? Because the people at the time all knew that light had to be a wave. And now we've come to this point where people are like trying to make fun of people when they present the argument that all waves require a medium. Yes, all waves require a medium. This isn't some gotcha. This is just basic universe. This is what happens. All waves, by definition, require a medium. So if you're saying there's a magical electromagnetic wave, it must be flowing through a medium, not through an empty void. Crazy, man. Okay. Thank you, Matt, for that other follow-up cookie. Why was Einstein always the figurehead of science and Tesla's work shoved to the side? Those are going to be questions for the ages, but I absolutely guarantee you that Einstein will be proven incorrect about the photoelectric effect, and Tesla will be proven correct that it's all based on resonance. And it should be obvious, like when Dr. Yu pulls up the what is it, the quantum, what is it, that one? Crap, I forgot the name of it. Anyway, you pull up the thing and you show that if you, just by showing two polarized lenses out of phase, light doesn't get through. If light was a particle, it would go right through, right? If it was infinitely small, there's no way that polarized lenses should prevent it from getting through. There really shouldn't be much of an argument after that. Like, how can you still present the idea that light's a particle? It just didn't feel like being a particle when it tries to go through a polarized lens. Two out of phase polarized lenses. Yeah, and then Matt also says, wow, that medium being needed for wave canceling out vacuum just blew my mind. Yeah, it says that's one of those things where like even I had never heard that for 40 years of my life. And the moment I heard all waves require a medium, so it can't be a vacuum, it just seems so obvious. And you wonder, and like that's actually probably why physicists in the early 1900s were just crapping all over Einstein. Because they were going, there must be a medium that we're living in. It has to be. A couple of these other donos, Stanley Raven came for the mystery, stayed for the science. Thank you guys. I hope you appreciate it. Come back for Friday too when we check out Randall Mills and the hydrino stuff. So I think I mentioned this before, but I got in touch with somebody who did research, like lots of research on Randall Mills and hydrino theory. And I'm going to interview them for Hard Truths after Randall Carlson probably. And I asked them before I interview them, I want to kind of come in a little bit blind. I want to learn during that interview. But I said, like, what's your opinion after researching it? After spending all this time researching Randall Mills. And they said, going to end up winning a Nobel Prize and changing the world. Wow. It's going to be an interesting one. Okay, some of the other donos. Thank you. It's about our Merkaba. I don't know what this means. Probably a spiritual thing. Thank you very much for that donation. Consider the lilies. Contribution towards the purchase of a new sign. Yeah, oof. Our sign's on life support, chat. Actually, no, there's like just a thing in the back that needs to be fixed. I'll probably just have get somebody to do it for me. I love purple things. Honestly, Einstein was probably paid off by the gatekeepers. I think we're overthinking it ourselves. I don't think he was paid off. I think that it's just human nature. Human nature, we're very tribal. And I think that happens in science as well. And that's what I think happened here as well. Whoa, is this a lot? Is that a lot of money, chat? It's red. Wow. Thank you very much for a questionable amount of monies, but thank you. Do you think classified projects achieved large-scale negative energy densities, or more likely, they're using inertial mass reduction and normal EM anti-gravity? And regarding image theory, you said it was a small NED rather than large scale. I assume you're that net energy density. Is that what you're saying? NED? Yeah. So especially because you donate a huge amount, they are definitely using negative energy densities. Negative energy density is in like the Casimir effect. And my guess is that whatever they're doing with the hydrino is also showing a negative energy density. So I think that the hydrino is them figuring out how to use negative energy at the atomic scale, the same way that the Casimir cavities effect works. Essentially like a trampoline. Pull a little energy out, move it over here, goes back to normal. Go over here, pull a little energy out. That's it. Simple as that. Have they been using that? Absolutely. And they've been using that to produce fusion. They've been doing that to produce cold fusion. And it's a low energy phase transition. Why? Because the plane, that zap around the plane is relatively small. If that was a high energy phase transition, I would expect like a massive blast. The clouds not like shifting. The clouds move like a little bit, like there's a little bit of a disturbance, but the clouds should get blasted away. If that was like, if there was a shock wave, there's no shock wave. So that has to be a negative energy event. A negative energy event must produce no shock wave. And it must basically be like looking at something phasing through a mirror. Like that's what it looks like when the plane disappears, is like something just phasing right through the mirror. And all they've done in the MH370 videos to demystify it, to explain why it's not aliens, all they've done is scale that effect up from the atomic level all the way up to these balls of plasma, which are just huge atoms. Bose-Einstein condensate, a coherent ball of atoms of plasma. And they use, and here's the genius thing, they use the same concept that we just learned about, the stopping voltage. That's it. How is the plasma staying stuck together? Because the stopping voltage prevents anything from being leaking outside the bubble. Just have your magnetic field powerful enough so that nothing leaks outside the bubble. That's it. The air itself is a natural insulator anyway. That was another thing I realized about this when I was like, oh, the stopping voltage. I was like, this is the same concept to confine your plasma. Just have, if your stopping voltage is high enough, your plasma is not going to dissipate. It's how powerful is your magnetic field? The more powerful your magnetic field, the easier it is to confine your plasma. So there you go. Thank you very much for that huge donation. I appreciate it. Let's get back to, there's a couple more pieces from this that I want to take a look at here. Oh, and so one of the other things he explains here, which is pretty cool, is that Max Planck kind of cheated in quantum mechanics. So Max Planck realized that there was this stepping stone scale. He realized there was this scale, but he didn't know how to explain it. He didn't know, he didn't know where is this coming from? Why? Why is this scale there? So Max Planck was smart and he said, I don't need to explain it. All I need to say is here's Planck's constant, the value that's been determined for the slope. And here are the numbers. N equals 1 through infinity. N equals 1 through infinity is the stepping stones. I don't care what the size of the steps is. I don't care why the steps exist. Here's the math that shows how it works. That's what Max Planck did. He just said, here you go. Here's the math that shows how it works. I'm not going to explain it. Which is funny because it makes me think about this video from Leonard Susskind when he was asked about zero-point energy. Wait, which one is it? This one? I think it's this
Understanding, one. If you remove matter and you remove radiation, what causes the electric fields? Like, what's the perturbation and what?
I can't answer what causes it. I can tell you that the uncertainty principle requires it to be there.
But we're making the assumption there is no electric field, there is no mass. I thought you...
Did I say there's no electric field?
So de Sitter space has only the dark energy. Or
right.
Okay.
It has no real photons. It has only the zero-point energy.
Okay, you can have an electric field without real photons.
It just doesn't have any charges.
It's there anyway. The field fluctuates anyway. It doesn't need charges.
Right.
And it does have charge, actually. The field does have charge. So what's crazy is that you see how Max Planck avoided the issue. Why? Why is it like this? You see when talking about zero-point energy, Leonard Susskind avoided the issue as well. They never will answer the why. Although, to Einstein's credit, he did try to answer the why, the photon theory. But now we see that that theory is outdated. So Planck kind of cheated. He kind of cheated. Now let's get back to this. And this is the conceptual explanation right here for how this came about.
This is where he realized if the spoon size depended on the color of the water. So if you have high frequency water, you have bigger spoon size, and low frequency water meaning smaller spoon size, then he could probably explain the experimental results. So he comes up with this random condition that the minimum quantity of water that you can transfer, the quanta, the size of the quanta, should be proportional to the frequency of the water, frequency of light. And again, remember, he's only doing this to fit the experimental results. It has no physical reason whatsoever.
How many times did you just say he's just doing this to fit the results? Max Planck basically saw the result was E equals HF. Energy equals Planck's constant times frequency. Simple as that. And he realized somehow a quanta can be shift changed. The size of the quanta, the size of the spoon can be changed by changing the frequency. Do you guys realize why frequency is definitely the answer now? Tesla was no doubt correct. Why? Because all the math of quantum mechanics about photon theory is all directly connected to quantum mechanics. And it's all related to waves, not particles. It's related to waves and frequency and spin. Not related to little apples flying around through the sky. What we see is F equals ma, Newton's famous theory. That's only on the macro scale. When you really dig right down to what we're actually dealing with, it's all waves. Okay.
It captured the essence of what Planck was trying to do without having to get into the details of the blackbody radiation and all of that. But now the big question is, did it work? And Planck says it half worked. His strategy worked perfectly, and he was able to perfectly explain the experimental results. Yay! But he wasn't able to get rid of his constant. He found out to make all of this work, that constant had to have a particular value. And that value is this. Yes, very close to the Planck's constant accepted value that we have today. But think about what this means. This meant that it was no longer just a counting trick. It was physical reality, that nature is indeed transferring water in some minimum quantas. But Planck hated this idea. That was never his intention. He never wanted to quantize anything. If water is continuous, why is nature forcing you to, restricting you to transfer it one spoon at a time in a multiples of a particular spoon size? Why was nature doing that?
So, why is nature doing it, chat? It's funny that anybody in my chat can probably answer the question for my man Floathead Physics right there. Is that everybody would probably say why? Because of resonance, because it was never about atoms being shot into something. It was always about resonance interacting and frequency. And so then Einstein comes in, and Einstein says, we're going to think about the water like ice cubes. We're going to think about it like ice cubes, and we're going to change the size of the ice cube. And this is where the photon theory came from.
Is what Einstein called the photons. So you can clearly see it was Einstein who came up with this revolutionary idea of photons. And not Einstein. Bravo, Einstein. Bravo. Truly out of the box thinking. But the big question now is, can this explain the photoelectric effect better than the trigger hypothesis? Let's find out. According to Einstein, light is not made of waves, instead of particles like ice cubes. And he says when you shine light on metals, the electrons have to absorb one entire quanta, the entire photon. You cannot absorb half of it. Okay. So What happens now if electron absorbs the entire photon? Now, if the photon doesn't have enough energy to kick that electron out, well, then the electron will just re-emit that photon back. And now even if it absorbs another photon like this, again, it will re-emit it back. So look, if you're shining light whose photon energies are too...
So I like the idea of it re-emitting it back, but this idea that like it has to absorb this one photon, they're just a roundabout way to explain away resonance, right? You could explain this exact same concept could be used to explain resonance. It's just more confusing way to explain it in a way that uses a particle that we don't need, basically. That's the idea here.
Too small to kick that electron out, you will not get photoelectric effect enough that it can kick out an electron. And now if you further increase the frequency, then the energy of a single photon becomes even more. So when the electron absorbs, it gets even more energy, and that's why it'll come out with even more kinetic energy. This now perfectly explains why, as the frequency increases, since the photon's energy increases, it transfers more energy to the electron, and that's why the kinetic energy will increase. That's why the kinetic energy, or the stopping voltage, depends on the frequency of light. And of course, if you were to increase the intensity, what does it do? Well, it just increases the number of photons. So that won't affect the energy transfer to a single electron. But now, since there are more photons, more electrons.
So what's the alternative answer? Why are more electrons being released when you increase the energy? Well, the answer is actually the same. If you're increasing the energy, you're just making more waves. Or you're increasing the amplitude, right? Which is the same as stacked waves on top of each other. So you can look at an increase in intensity of brightness is actually just more waves being stacked up. And if you're adding more waves and hitting it, then yes, if you're not changing the frequency of the wave, you're not going to change the type of interaction. You're just going to get more interaction. So if you increase the intensity of light, the reason why you get more electrons coming out is the obvious. You're hitting that thing with more waves. I mean, it's conceptually, of course, not in reality. So you should get more electrons come out, but you're not going to get them come out with more energy unless you change the frequency. And this could be, the analogy here could be, imagine two spinning things and getting them to align correctly. If they're not aligned correctly, the amount of energy that comes out is going to be relatively low. If they're aligned correctly, you might get a huge energy release. Okay. Now the last part, I love this part. So how did this all go down? How did the photon theory go down?
The already established wave model of light. We have century worth of experiments confirming that light is a wave, like interference and diffraction and so much more. And now this patent clerk comes out of nowhere and says that, hey, all that is wrong and light is not a wave, it's made of particles, and you expect people to accept that? No ways. In fact, this idea was so revolutionary, and people hated it so much that people actually thought that this was Einstein's biggest blunder. I mean, take a look at this recommendation letter written by Max Planck in 1913. You can pause and read this. So he praises Einstein over here, and then he says that he may sometimes have missed the target of his speculations, as for example, in his hypothesis of light quanta cannot really be held against him. Oh man, this aged well. But second,
wow. So Max Planck basically bitched Einstein about the photoelectric effect. His hypothesis of light quanta cannot really be held against him. He won his Nobel Prize for that. Einstein won his Nobel Prize for something that I'm pretty sure now is going to be invalidated. Like photons are going to get invalidated as a theory. And we revere Einstein for all the wrong things. Well, that's not true. We revere him for the right things, but the thing that he got the highest praise for, probably going to be some of his worst work. Pretty funny. Now, let's finish.
Secondly, the photon theory challenged a Nobel laureate. Who are we talking about? Leonard. That's right. Leonard actually won a Nobel Prize in 1905, the same year Einstein published all his beautiful papers on special relativity and photoelectric.
So the reason why I wanted to bring this up is that the universe just repeats itself. So what happened before? The reason why the photon theory was rejected was because it invalidated Nobel Prize winners. Photon theory invalidated Nobel Prize winners, so nobody wanted to believe it. And now we're in a situation again where people have won Nobel Prizes based on work that's going to be proven wrong, and now they don't want to admit that they're wrong. People have decided that energy comes from wires and that warp negative energy is not real and that 0 point energy is not a significant thing. And all of these people are going to be proven wrong. And so it goes to show you that the reason why I started tonight with that clip of science being a bitch sometimes is that we really are just stuck in a cycle, aren't we? And when I talk to Randall Carlson tomorrow, this is why I want to talk about the idea of cycles. There's cycles in everything. Everything is waves. Why is there not cycles in technology? Why is there not cycles in civilization? We are repeating the same mistakes over and over and over again. The same bullshit that we did to Einstein, we're now doing again, holding ourselves back once again. We never learn from our mistakes. The mistake was idolizing people instead of analyzing results from an objective lens. The last thing I want to say on this for tonight is that I've been reading some of the comments. I read the comments. I read the criticisms. I'm not afraid of any of that crap. And I see people say stuff like, you know what? I don't agree with Ashton. I think he's a dickhead. I think what is some of the stuff people says? Some stuff people says wild. People really have a crazy view about me. He's a narcissistic, egotistical asshole, but I think that he might be right. The big lesson I want people to take from all of this, when one day this is all proven to be true, is that we need to stop trusting authority, stop trusting experts. I imagine a world where this gets proven true, and then a bunch of people come to me for all their answers because, oh, Ashton was right about that plane and teleportation. He must have all the answers to everything. No. Just because I get something right, even if it's a crazy, impossible thing to get right, doesn't mean I'm somehow the guy that knows everything. This is the bullshit that we fell into. We start idolizing people like Einstein, thinking they can't be wrong about anything. This is the expert bullshit that we get stuck into, where we just think that, oh, it's all about credentialism and who's the smartest. That person's right about everything. That's what we need to learn, is that even if you disagree with someone, even if you think they're a shitty person, they can still be right. We can still agree on things. So part of me is glad that people think I'm this asshole person that I'm not, because I want that lesson to be learned as well. So thank you guys for the joining me on my live stream here tonight. Last donation is Truth is Treason. Thank you for following and supporting. And yes, Ken Wheeler's Light and Magnetism. I think that Ken Wheeler is on the mark when it comes to this stuff. But the other part of it that you're going to learn is that if you haven't already, it's not just being the smartest guy. It's not being the guy that has the answers or knowing the secrets. It's figuring out how to communicate that to the world. This whole thing is absolutely, we're in the middle of a major propaganda war. There was a new UFO whistleblower that came out. And it's almost like they just looked at the feedback from the focus groups and were like, you know what, guys, the last whistleblower talked a little bit too much about the psychic powers and summoning egg orbs and shit like that. Let's have this new whistleblower be more straight cut. This one's going to appeal to the working class man. He's not going to talk about the psychic power stuff, right? It's like you see all this bullshit going down and you're just like, how can people even buy into that anymore? It seems like such contrived nonsense. And you see it in the academic community. You see it in the UFO community, you see it in the media, and you see it in the government. So whatever people want to believe, whatever people want to think about me, I hope at the end of the day, we learn, let's judge ideas on their own merits and not have people be guilty by association. I hope you guys have a great night. Thank you, MH370X. I love y'all. You're the best. Friday, let's talk about brilliant light power. hydrino theory, and negative energy. Who out there is covering up free energy for the world? We're going to see if we can find out. I love you guys. Later. Oh, wait. I almost ended the stream without doing our goodbye thing. Here we go.
Out in the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate. Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum, squeeze so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course. Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. Thin shell formalism, plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Unknown forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crump shines, bringing truth to light. Through his music, we'll explore the night with wormholes and stars.